This recording is for Pre-Algebra Chapter 3, Lesson 3, using formulas. And today's quote comes from Horseradish, Bitter Truths You Can't Avoid by Lemony Snicket. And the quote today comes from page 100, which I'm finding real quick. Page 100. Where are you, page 100? Page 100. When someone is crying, of course, the normal thing to do is to comfort them. But if someone is trying to hide their tears, it may also be noble to pretend you do not notice them, so they will not be embarrassed. All right, using formulas, hopefully something you will not cry over, or even try to hide your tears over. A formula is an equation that shows a relationship between quantities that are represented by variables. So one of the basic ones is the distance formula, which is distance equals rate times time. And the variables that we're using are distance for D, R for rate, and T for time. Okay? So let's go ahead and just try using this out, all right? So the distance formula is basically how far you're going to go, the distance you're going to go, based on how fast you're going and for how long you went that fast. So if I'm going 15 miles per hour, let's do something even more basic. If I'm going 1 mile per hour for 1 hour, my distance is only 1 mile. Whereas if I went 1 mile per hour for 2 hours, I've gone now 2 miles. Okay? And just a reminder that the word per means multiplication. Okay? All right. So let's suppose you're traveling 162 miles for 3 hours. We want to find your average speed. Speed is also known as your rate. Okay? Well, let's figure out what we do know. We know that the distance is 162. Actually, I've already done this. So 162, and the time is 3, and the rate, well, we don't know. Well, since we don't know the rate is going to be our variable. So what I'm going to do is I'm going to plug this into an equation. Oh, let me see here. Let's see here. Let me erase this. There we go. So let's go ahead and plug this into an equation where distance is D. Oops. Distance is D, which is 162. My rate is my variable, and my time is 3. Okay? So we're going to solve the equation. Well, what is happening to x? It's being multiplied by 3. So the opposite of multiply by 3 is obviously divide by 3. So I'm going to divide by 3 on both sides. And then 162 divided by 3 is 54. So your rate was 54 miles per hour. Okay? So if you'd only traveled 1 hour, you'd only gone 54 miles. If you traveled 2 hours, it would be 54 times 2, which is 108. And then if you traveled for 3 miles, it would be like adding another 54 miles, which is 162. You guys got it? Rate is times time equals distance. Okay? So how fast you're going for the length of time you're going is going to equal how far you went. All right. There you go. Here's another problem. We have 273 miles. And we had a rate of, we have a rate of 10.5 miles per hour. So if that's the case, we're going to do 273, because that's the distance, is equal to my rate, which is 10.5, and it's going to be multiplied by time, and we're trying to find time. To do that, we're going to divide by 10.5 on both sides, and it's going, because this was actually miles per year. Or inches per year, actually. It was inches per year, not even miles per year. So where's that? It was inches per year, by the way. So this might be how fast the tectonic plates are moving. You know, if it takes it at a rate of 10.5 inches per year, how long is it going to take to go 273 inches? Well, it's going to take 26 years. Okay. Next problem is the cricket formula. You're going to have to do this in class tomorrow, so get used to it. You can use the number of chirps a cricket makes in a minute to determine the temperature in Fahrenheit outside using this formula. The temperature outside in Fahrenheit is equal to the number of chirps divided by 4 plus 37. So if if I have a cricket and I timed it for a minute and I counted 96 chirps, that's a lot of chirps in a minute. It's going to help me determine how warm or cold it is outside in Fahrenheit. So I'm going to plug 96 in for n, and then I'm going to use the order of operations. So 96 divided by 4 is 24. 24 plus 36 is 61 degrees Fahrenheit. So based on the number of chirps, we can tell how warm or cold it is to the degree. Actually, it's pretty awesome. All right, next formula you're going to have to use a lot is a rectangle perimeter formula. It allows you to determine the distance around a rectangle using the length and width of the rectangle. So the formula is perimeter is equal to 2 times the length plus 2 times the width. So if length is 27.3 centimeters and the width is 16.8 centimeters, I plug it into the formula, and I'm going to get 2 times 27.3 plus 2 times 16.8. Solve in parentheses, basically order of operations first. So I'm going to have 54.6, which is 2 times 27.3, and then the 2 times 16.8 is the 33.6. Add them together and we get the perimeter of the entire rectangle, which is 88.2 centimeters. All right, last but not least are the 2 other formulas you're going to have to use at some point. You should have the area formula memorized. It's just length times width, where you can use this for a square or a rectangle. And then from Celsius to Fahrenheit, I don't expect you to memorize the Celsius to Fahrenheit. Mr. Michaels might make you memorize it, our science teacher, but you don't have to memorize it. I'll give it to you every time you need it, but it converts Celsius degrees to Fahrenheit degrees. So for this one, you're going to plug in Celsius. Let's say it was 35 degrees Celsius. I'm going to plug that in for Celsius, and so it's going to be 1.8 times 35 degrees Celsius plus 32. So we've got 35 times 1.8 is 63. 63 plus 32 is 95 degrees. So actually, make that 5 prettier. 35 degrees Celsius is actually a pretty warm day. It's a pretty warm day. Normally, we like it around the low 30s to high 29s in degrees Celsius when we're dealing with temperature. All right, guys, that is it. See you in class tomorrow. Bye.